Hello students, welcome to the physics class with Sujit sir. Today we are going to start a new topic. Before going to start that topic, I want to show you a video.
The two bar magnets, when iron pieces are poured near to it, you can see iron pieces are arranged in curved lines called lines of force.
In this video, you have seen that the flux, the lines of force. Here you can see these are straight lines of force. Just imagine that in place of that two magnets, there are two charges where the lines of force due to the two charges have been created around it. That lines of force can be either straight line or a curved line, but in that case you have seen a curved lines of force. So here these are straight lines of force are straight lines. When straight lines of force passes through a surface perpendicularly or normally, then it is called electric flux. So today topic is electric flux. What is electric flux? Electric flux linked with any surface is defined as the total number of lines of force that you have already seen in the video passing perpendicularly or normally through that surface is called lines of electric flux. That is called electric flux.
The number of lines of force passing perpendicular to the surface is called electric flux. It is denoted by phi and it is a scalar quantity.
Let d phi be the electric flux through a small area element ds due to an electric field E at an angle theta with ds. So ds is a area vector of small surface area. Okay, ds is small surface area. What is the direction of ds vector? Area is a vector quantity. What is the direction of area vector? You can see normal or perpendicular to the surface is the direction of that area vector. So here ds vector, it is the area vector here, ds vector, it is the area vector here, ds vector, it is the area vector here, ds vector, it is the area vector which is perpendicular to the surface, Here you can see d phi is equal to d phi means electric flux through small area ds vector. So d phi is defined as dot product of electric field and area vector, that is E vector dot ds vector. So it is E ds cos theta. If d phi is the flux through small area ds vector, then what is the electric flux through total surface, not for small surface, for total surface? We can determine the total electric flux by integrating both sides. Okay, so when we integrate d phi, it will be phi, and when we integrate E dot ds vector through line integral, surface integral of E dot ds vector, so it will be vector E ds cos theta. When we integrate ds, it will be s, so it will be E s cos theta, that is equal to E vector dot s vector. Electric flux is a scalar quantity, but it is a property of vector field. Electric field, vector field means electric field, it is the property of electric field. SI unit of electric field is, electric flux is Newton meter square per coulomb, Newton meter square per coulomb or Joule meter per coulomb.